Alright, question 5. A large balloon of volume 1500 cubic meter is filled with helium gas at a pressure of 120 kilopascal and temperature of 27 degrees Celsius. The balloon is then released and it rises. At a certain height, the temperature of the helium in the balloon decreases to 13 degrees Celsius, but the volume of the balloon remains constant. So if the balloon remains constant, the volume of the balloon remains constant, this is an isochoric process lah. Okay, so what is the pressure of the helium in the balloon? We can use pressure's law, which is P1 over T1 equal to P2 over T2. Okay, where P1 is 120 kilopascal and then T1 is 27 plus 273 303 Kelvin, and then T2 is 13 plus 273 286 Kelvin. So from here you should get the pressure to be equal to T2 over T1 times P1. The answer, I think, based on what I answer, it should be 114.4 kilopascal. Instead of 104, it should be 114.4, because in the answer scheme, instead of 273 ni tambah dengan 13, dia buat 273 minus 13 pula, which is why I don't think it should be like that, because we are converting it into Kelvin kan. Okay, so so that is my answer. And then what is the change in internal energy of the helium gas? We are gonna use delta U is equal to F over 2 nRT. Okay, which in this case for isobaric, isochoric, it is equal to delta U. Actually, I don't remember. Let me check. Oops, this is chapter 13. Chapter 14 for what is it? Isovolumetric. Isovolumetric work is this one. Q is equal to delta U. Q is equal to delta U. Why should I? Alright, no, sorry. Okay, so we are just gonna use delta U punya formula, which is F over 2 nRT, right? So nRT ni kita boleh dapat dari PV equal to nRT. So just delta U equal to F over 2 PV lah. Okay, so P di sini ni since it is changing, it will become delta P and then V. So this one is 3 over 2 and then V is 1500, and then 114.4 minus 120 kilopascal lah. Yang ini kilopascal times 3 minus 120. Okay, so the internal energy will then become negative. Okay, this one I have to calculate. 1500 times 114.4 minus 120. So it will become negative 12.6 megajoules. Okay, right, so that is the solution for question B. And then question C, what happened to the change in the internal energy of helium? So since it is negative, the internal energy decreases because it dissipated as heat. It dissipates as heat lah. That's why there is a decrease in the internal energy of the system. Alright, so yeah, that is the solution for question number 5.